Hi, welcome back to Chemical Engineering Statistics. Today we will discuss about fundamentals of hypothesis testing. In the previous section, we illustrated how a parameter can be estimated from sample data. However, many problems in engineering require that we decide whether to accept or to reject a statement about some parameter. The statement is called a hypothesis, and the decision-making procedure about the hypothesis is called hypothesis testing. We like to think of statistical hypothesis testing as the data analysis stage of a comparative experiment in which the engineer is interested, for example, in comparing the mean of a population to a specified value. The hypothesis statements are always in pair. We always have null hypothesis H0 and alternative hypothesis H1. The null hypothesis always contains equality, while the alternative hypothesis may contain unequal or less than or more than. For example, let's formulate the hypothesis H0 and H1 from the claim of the average weight of PT Semen Indonesia Portland cement products is 50 kilograms per bag. The initial mathematical expression that we can build is mu, the average, the mean of the population, is 50 kilograms. If the above statement is false, then the correct is mu is not equal to 50 kilograms. The first statement contains similarity, and the second statement contains dissimilarity. Therefore, the hypothesis statement becomes null hypothesis H0 mu equal to 50 kilograms. Alternative hypothesis H1 mu is not equal to 50 kilograms. Because we use probability distribution to represent populations, a statistical hypothesis may also be thought of as a statement about the probability distribution of a random variable. The general procedure for testing the hypothesis are as follows. First, we have to determine the significance level, or alpha, for drawing conclusion. Typically, we use 0.01, 0.05, or 0.1. Next, we have to formulate the hypothesis statement H0 and H1. Then, we calculate the value of hypothesis testing from the sample data. The critical value should be found by using or determined by significance level, degree of freedom, and the properties of the alternative hypothesis. After that, we examine whether the statistic test, the one that we calculate at number 3, goes under the rejection or non-rejection curve of null hypothesis. Lastly, we formulate the final conclusion based on the initial claim that you want to prove. Use the language "there is enough evidence" or "there is not enough evidence." If the sign of the alternative hypothesis is unequal, the area of rejection lies in the left tail and the right tail of the normal distribution. This is called as two-sided test. If the sign of the alternative hypothesis is less than, the area of rejection lies in the left tail. If the sign of the alternative hypothesis is more than, the area of rejection lies in the right tail. These are called as one-sided tests. This decision procedure can lead to either of two wrong conclusions. Rejecting the null hypothesis H null when it is true is defined as a type 1 error. The probability of making a type 1 error is denoted as alpha, which is the significance level of the test. Next, failing to reject the null hypothesis when it is false is defined as type 2 error. It is worth to note that type 1 and type 2 errors are related. A decrease in the probability of one type of error always results in an increase in the probability of the other, provided that the sample size n does not change. An increase in sample size will generally reduce both alpha and beta, provided that the critical values are held constant. That's all for now. See you in the next video.